Tonight I want to talk about biology, which is my background and my journey from that into what I do now, which is broadcasting. I create radio programs, documentaries and series for the CBC and WNYC. And essentially, a big story that was always told to me about biology as I was studying it is, of course, that of Darwinian evolution. This is the linchpin, the meta-narrative that makes biology make sense in the midst of all of its complex confusion. And we know this as being that underlying natural slow process by which characteristics become more or less common in populations based on interactions between inherited genetic traits and environmental pressures. But of course, this has not always just been understood as true. In 1859, that was published, but then in 1907, we have Henry Bergson, the French philosopher, who comes out with vitalism, which is a concept that still sticks around with a lot of artists today, but has been widely disregarded in scientific circles, that life can't be reduced to such mechanistic properties. It never is about chemical or physical forces. It's about a creative aspect to life that we cannot reduce and understand. Now, this was contested by Stéphane Leduc, who in 1911 published what he believed to be the first synthetic biology, these filamentous growth patterns that he found in what were his mushrooms and his fish and his gardens were nothing more than metals and inks combined together in laboratory environments. And he found this to be the first synthetic biology, which is a mechanistic process that we can use to understand how life comes together from chemical components and mixtures. Synthetic biology today, 100 years later, also takes this engineer's mindset towards how we can attain life, engineer living systems to suit human needs, create cheap biofuels, medicines, vaccines, food items for us by co-opting simple organisms like bacteria, turning them into factory floors to produce such values for us. We have a few ways of doing this. Whole genome engineering you might have heard about in 2010. Craig Venter created what is supposed to be the world's first organism with a computer as a parent, because we can sequence DNA, we can read DNA so widely now, we can also write it from scratch. Genetic devices and circuits. So this is the idea whereby we can create controllable kind of Lego bricks that clip together and functions that we can understand that make organisms do specific things, like maybe turn orange in the presence of arsenic, a biosensor, to tell us something about the environment that we're working with. And then there's also protocells, which is the last kind of compartment area of synthetic biology that we're working with right now, which is trying to understand how we may have first evolved into complex organisms from this primordial soup story that we tell ourselves about where evolution comes from, whereby there's an uncontrollable mixture of chemicals that found the right formations at a specific time within specific conditions that then was able to take on emergent properties. And this scares people. People think that we're playing God because we're synthetically, biologically engineering our environment. And Stuart Brand, a very famous futurist who's involved with a lot of emerging technology, says, yeah, of course, we are as God as we may as well get used to it. Because right now we are dealing with a lot of environmental problems. We are in this sixth extinction. This is an extinction that has not been found to share common characteristics or causes with the other five that have come before. Of course, we've got new uses of land or demise of ecological systems, overpopulation of the species, our species, demise of other species, introduction of alien species, and so forth. And he says that what we need to do with this technology, it's an actual responsibility, is right the wrongs that we've created. So he has amassed all these scientists around the world who are working on de-extinction, which is the mission to revive extinct species through synthetic biology, which is something that I'm making a documentary for CBC Radio 1's Ideas on right now, which is what I wanted to talk to you about. And so this guy, Ben Novak, 26-year-old scientist, hired by Stuart Brand to revive the passenger pigeon. Carla, I'm so happy you talked about pigeons. Thank you so much. That was awesome. Because pigeons are something I've been paying attention to. Ben is trying to revive them by sequencing their DNA and editing living common pigeons to match that, such as the band-tailed pigeon or the rock pigeon, which are the things that Carla talked about earlier. And the ROM, which we have here, actually houses the world's largest collection of taxidermied passenger pigeons. And so scientists who have been trying to bring this bird back to life, which used to swarm in flocks of billions, there's a famous flock that went over southern Ontario in 1859 that was 14 hours before it got overhead, like huge things. So if we bring back a few, can we really bring back the whole breed? We don't know. But of course there are lots of charismatic megafauna that people are trying to bring back, like the mammoth. And so we love these species because for once they kind of make us feel humble in their presence. And people say all the time that we can bring back mammoths, you just like take their DNA and swap it into an enucleated cell of a regular elephant, and then it'll give birth if it's surrogated. But it's not that easy. Look at this Siberian sample of mammoth tissue that we have to work with. We have to extract DNA from that, which is also co-contaminated with bacterial artifacts and all sorts of other messes that we have to mine through to then actually create hybrid life forms. So Hamilton's own Henrik Poinar, he's really great. He's the de-extinction expert on mammoths. He is at McMaster University. If you're interested, he's talking Toronto Reference Library on Friday at 6:30 about de-extincting this thing. Wonderful thing, wonderful creature. But also what's so cool about him is that he's not only a paleobiologist himself, his father is the famous paleobiologist that inspired Michael Crichton to write Jurassic Park, because he has the original amber-encased mosquito. And so right now there's an exhibition happening in Dublin at the Science Gallery where artists are creating provocative objects and interactions around what de-extinction might mean and other synthetic biology tactics. One of which is, I want to deliver a dolphin. Instead of always taking natural resources from our environment, how about we deliver with our own reproductive resources something back to the land, so endangered species or de-extincting species in our own wombs, and that this artist says will fulfill the really natural desire and need of the woman to give birth to something, even if it's in a bad, overpopulated human ecosystem. War of the Worlds. Do you guys know this famous radio broadcast? Orson Welles' 75th anniversary this Halloween. He's so cool. And all I want to say is that I can't explain what this is about right now because there's not enough time in 20 seconds, but in the spring, I'll have an Orson Welles-inspired documentary on CBC about de-extinction, if you want to listen. And although I don't think we ought to necessarily do this the way that Stuart Brand does, I think what we ought to do is converse amongst ourselves, no matter what our discipline is, about our shared biotechnological futures, especially in a Canadian context whereby we have Harperian government trickle-down effects that are silencing our scientists. Thank you very much.